In this video, we are going to study about domain of radical functions. Radical functions, when we are right in the root here, and for the radical functions, this n value is important. With respect to this n value, the domain is going to be R or positive numbers. I'm going to explain how it is going to be for the positive numbers. But firstly, I want you to remind about the name of this n value. This n value is called index, firstly. And there are two options here. Index will be odd or index will be even. If index is odd, the domain is all real numbers. This because of the cubic root or fifth root of the things. If a cube root of 8 is equal to 2, because 2 cube is equal to 8, cube root of minus 8, it's going to be equal to minus 2. So for the cube root, fifth root, or for the odd integer root, the positiveness or negativeness is not important. Positiveness, negativeness is not important. But for the even integer, when the index is even, what is written inside the radical expression, it must be gx must be greater than 0, greater or equal to 0, sorry. Or, generally I'm not using this part, or gx must be greater than 0. What I mean? We know that square root of 4 is equal to 2. But square root of minus 4 is not element of real number. It is not defined in real numbers. So we don't have negative number for the roots. This is square root. And when the index is even number, the number what is written here, or the expression what is written here, it must be positive. So we are going to check the positiveness or negativeness. Here the both example what is given here for the even, because this is 2, when it is not written we know that it's square root of 2. For the both example, the given functions are quadratic function. I don't want to solve first the quadratic function. First I want to solve linear function. Then I'm going to solve the quadratic function, but I'm going to record another video for the inequality of the quadratic function. What is the domain of this function? Here, what is given as an expression? This is radical expression, and the root is 2. So the domain, for the domain 3x plus 6 must be greater than 0, and for this domain 16 minus 2x must be greater or equal to 0. So we should solve these are 3x is greater or equal to minus 6, and x is going to be equal to greater than minus 6 over 3, and x is going to be greater or equal to minus 2 here. And the second one, for the second one, 16 is going to be greater or equal to 2x, or minus 2x, we can do like this also. Minus 2x, we will leave this one here. Minus 2x is greater than minus 16, it's going to be minus 16. X must be greater or equal to minus 16 over minus 2. Sorry, I made a mistake here. The mistake that I made, the sign of the side of the sign. And it's going to be equal to minus 16 over minus 2. Why greater than becomes smaller than? Because we are dividing by negative number. When you divide by negative number or multiply by negative number, you should change the side of the sign, and it's going to be equal to x is greater or equal to 8. It's going to be minus 16 over minus 2 is going to be 8. We have to be careful about this step here. Okay, x is greater than minus 2. This can be a solution. Also, we can write this one in terms of set builder form. Sorry, domain of f can be written as is equal to from minus 2, numbers greater than minus 2 it represents here, and minus 2 is included. When the boundary number is included, we are using closed parentheses. And closed parenthesis minus 2, and the numbers are going to till infinity, so domain is going to be minus 2 to infinity, or we can write like this: df is equal to, there is an x such that x is element of minus 2 till infinity. This is more formal solution. It's going to be. And the second one, x is less than 8. df, I'm going to write here again, df is going to be, I'm doing a mistake about this notation here, normally it should be double point here, x such that x is element of minus infinity side, I said at the beginning, if you remember. Here this is going to be closed, and here this is, we are going to close the parenthesis, and this is the domain of the set is going to be. Okay. Okay, these are the quadratic inequalities, because here x squared minus 2x minus 15 is going to be, must be greater or equal to 0, and here 16 minus x squared must be greater or equal to 0 is going to be. That's why these are quadratic inequalities. I explain in the video, in different video, how to solve the quadratic inequalities. That's why I'm not going to explain everything detailed here. X squared minus 2x minus, firstly, we are going, you know that we are going to factorize this one. X it's going to be, and here the factors of the 15 is minus 5 and plus 3. It's going to be y minus 5, because the result is equal to minus 2. So when you add them, minus 5 and 3, it's equal to minus 2. So this factorization is going to be true, which means x minus 5 times x plus 3. X plus 3 must be greater or equal to 0. And we know also this one. Here, x minus 5, the first critical point, x1 is equal to 5. It's going to be the second critical point, x minus x plus 3 is equal to 0. That's equal to minus 3 is going to be. With respect to that one, if I draw the table here, if I draw the table, the values are minus 3 and 5. It's going to be on the real number line. You remember the minus 3 firstly, then 5 is coming. Then the sign of x and x, both they are plus, so plus and plus. It's going to be plus minus plus. So we are looking for greater than intervals here. So it's going to be this interval and this interval is going to be in the solution. Since the sign is greater or equal to sign, we are going to use closed parentheses here, closed parentheses, and minus 3 and 5 is the boundary. On the other side we have infinity. Infinity side always open, it must be. Here minus infinity it's going to be, minus infinity minus 3 is going to be. So x such that x is element of, this is the set builder form of the domain of f is going to be. Okay, what about the second one? 16 minus x squared is going to be 16 minus x squared, it's going to be greater than 0. We know that 16 minus x squared is equal to 4 squared minus x squared is greater or equal to 0. It's going to be 16 minus x, 4 minus x, a squared minus b squared is equal to a minus b times a plus b. It's going to be. So the factors are 4 minus x and 4 plus x. It's going to be. And the first root, 4 minus x is equal to 0. x1 is equal to 4. And 4 plus x is equal to 0. x to second critical point is going to be equal to minus 4. I'm going to draw the table again here. Then I'm going to place the values. Here minus 4 is going to be on this side. 4 on this is going to be on this side, and minus infinity side plus infinity side. It's going to be on the real number line, how it is written. I ordered the numbers like that. Okay, then here we have one problem. We are not going to start with plus, we are going to start with minus, because one of the coefficient of the x is equal to minus. Minus, then plus, then minus it's going to be. And we are looking for the greater than interval. Here it's going to be that interval, and closed parenthesis, because this is greater or equal to 0, so the terms are included, minus 4 and 4 it's going to be. So x such that x is element of, this is the set builder form. When I close with the parentheses, this is going to be domain of f is going to be